Good morning, guys. Today we are going to start a series on Yocto. We'll learn Yocto, and then we are going to use Yocto to create our own embedded Linux images. So let's get started. So what are the four elements of embedded Linux? The four elements of embedded Linux are toolchain, which is bootloader, kernel, and a root file system. So toolchain is a compiler and other tools like assembler, linker, and loader, which is needed to create code for your target device. So everything else, the bootloader, kernel, and root file system, it depends on the toolchain. Then we have bootloader. This is the code program which initializes the board and loads the Linux kernel. Then comes kernel, which is the heart of the system. It manages system resources and perform interfacing with the hardware. Finally, we have the root file system. This contains the libraries and programs which run once the kernel has completed its initialization. So these are the four elements of any embedded Linux project: the toolchain, the bootloader, the kernel, and the root file system. One more element which we can add is collection of programs or applications specific to your embedded application or specific to your project, which will make the device to do what it is supposed to do. So embedded Linux application can be like weighing groceries, it can be a displaying movies, it can be a digital signage, it can be a media player, it can be controlling a robot or flying a drone. So this is the final element. So this all elements are of this all elements are combinedly we can call as an embedded Linux image. So if we want to generate if we want an embedded Linux image, it should have a tool chain, it should have a bootloader, it should have a kernel, it should have a root file system, and then it should have an application which actually perform the real task, like flying a drone or media player, etc. So what is Yocto? Non-technically speaking, Yocto is the smallest SI metric system prefix. We know M. We know M as means it is milli, which is 10 power minus 3, which is so Yocto here is Y. Y is 10 power minus 24. So non-technically speaking, Yocto is nothing but the smallest SI metric system prefix, which is 10 power minus 24. Now let's come to the technical thing. So Yocto, what is Yocto project? Yocto project, it provides open source, high quality infrastructure and tools to help developers create their own custom Linux distributions for any hardware architecture. So what he's saying is it provides open source and tools. It provides open source tools which the developer can use to create their own custom Linux distribution. So using Yocto project, developers can create their own custom Linux distribution like Ubuntu. You can create your own Ubuntu for your hardware. You can create your own Fedora or you can create your own OpenSUSE for your particular hardware. History of Yocto project is it was founded in 2010 in an effort to reduce work duplication, provide resources and information catering to both new and experienced users. And this was there is collaboration of many hardware manufacturers, like in many hardware manufacturers, open source operating system vendors, and electronic companies. So all of them they collaborated and they made this Yocto project. And Yocto is also a project working group of the Linux Foundation. So to understand the outcome provided by Yocto project, we can take the analogy of a computing machine. What you give as input to a computing machine, you give a set of data that describes what we want. It's our specification. So this can be, the data can be a kernel configuration, what kernel I want, which kernel version I want, what hardware I have, what all packages I need to be installed on the image, what all binaries needs to be present on the image. This we give as an input to the Yocto project. This is a set of data, this which we are telling we need this particular kernel version, and in this kernel version we need this kernel configuration. We have this kernel configuration, and we have this particular packages. We need these packages. And finally, the output which Yocto project gives is a Linux-based embedded project or a product. So it gives a Linux-based embedded product, which is nothing but Linux kernel, root file system, bootloader, device tree. It also gives you the tool chain. So this is an input. Input is kernel configuration, name of the hardware, and a lot of information you have to give as input, like which packages you want and all. And finally, you get an output, which is kernel image, root file system, bootloader, device tree, and toolchain. So to use Yocto, there are some prerequisites. You have to have 50 gigabytes of free disk space, and it should run on a supported Linux distribution. So it should run on, like, the supported Linux distributions are Fedora, OpenSUSE, CentOS, Debian, Ubuntu. And then there are these three packages which system should already be installed, like Git. It should have this version, tar, and Python. And then you have to install packages. Which package you have to install, it depends on the development system. I am using Ubuntu 18.04, so I have to install these all packages for my build system to configure to use my machine for Yocto. So I have already installed these packages. So I have already installed this. So you need to install all these packages, and this is mentioned in this particular link. If you go to this link, you can see this. All packages are being mentioned in this link. Now let's come in detail in Yocto. We have something known as Pokey. What is Pokey? Pokey is a reference distribution of Yocto project. So Pokey is a reference distribution of Yocto project. The word reference here means is example. So it's an example distribution. So you are going to create your own distribution, right? You need an example to take. You need an example to look how to create my own distribution. So Yocto project provides an example distribution or distro, which is Pokey. So Yocto project, it uses Pokey to build images. The images are like kernel image, system and application software for your particular target hardware. So at the technical level, it is a combined repository of the components like bitbake, open embedded core, MetaYocto BSP documentation. So it's a combination of these all repositories. We'll be looking into each and every term. An important point here is Pokey does not contain any binary files. It is a working example of how to build your own custom Linux distribution from source. What is the difference between Pokey and Yocto? So we till now we were discussing about Yocto, and now we came to Pokey. So what is the difference? The exact difference between Yocto and Pokey is Yocto, it refers to the organization. Like take an example for Ubuntu. The company behind Ubuntu is Canonical, and Pokey, it refers to the actual bits downloaded. It's like Ubuntu. So company is Yocto, and the actual source is Pokey. So the important point here is Pokey is an example, working example of how to build your own custom Linux distribution from source. So you can take Pokey and then you can modify it, and then you can create your own Linux distribution. So Pokey is a combined repository of this particular projects or components: bitbake, open embedded core, MetaYocto BSP, and documentation. So let's get more deeper into the terminology. So we need to know this terminology so we can easily understand our future lectures. So what is metadata? So non-Yocto world, metadata is a set of data that describes and gives information about other data. Coming to Yocto world, metadata, it refers to the build instructions. It refers to the commands and data which are used to indicate what versions of software are used, where they are obtained from, what all patches which I need to apply. So metadata is nothing but the build instructions. For example, take what should be the metadata for the kernel. What should be the metadata for kernel? It should be how to build this kernel. I have to use make command, I have to use make menu config, I have to use make install, make modules install. So these are the commands. And where I can get this kernel image or kernel source code, I have to mention the website or the Git repository where this particular kernel image is present. And then if I have any patches related to my hardware, I have to mention this. Which version of kernel I have to use, I have to mention this. So this is all known as metadata. So I have given an example of kernel image, and this applies to all the packages. Like it can apply to the Git package, it can apply to USB utils package. There are many packages. So all for each and every particular package, or for each and every thing which is used in the Linux image, you need to specify the metadata. So metadata in Yocto, it is a collection of configuration files. It has an extension .conf, recipes .bb and .bb append, which this has the extension of .bb and bb append, classes, which has an extension of bb class, includes, which has an extension of inc. So we'll be looking in, we have to understand all these files to better understand your code. You have to understand what kind of configuration files we have, and how is a recipe written, what are the different classes, and what are the includes. So if you understand all of this, then you will be easily understanding how to write your own custom Linux distribution. You can easily write your own custom Linux distribution, and you can easily debug while you're having any issues when you're building the image. So we said Pokey, it is a combination of so many projects. One is a BitBake. Then we said it is a combination of BitBake, Open Embedded Core, Yocto BSP, and documentation. So then we have Open Embedded Project. So what is this Open Embedded Project? From their website, Open Embedded Project, it offers a best-in-class cross-compile environment. It allows developers to create a complete Linux distribution for embedded systems. So you can see both are doing the same thing. Yocto project allows also to create a custom Linux distribution. And Open Embedded project, it also allows developers to create a complete Linux distribution for embedded systems. So what is the difference between Open Embedded project and the Yocto project? So the Yocto project and Open Embedded project, they share a core collection of metadata. So we have just now understood what metadata is. They share a core collection of metadata, which we call as Open Embedded Core. But however, the two organizations, they remain separate, each with its own focus. The focus of Open Embedded is to provide a comprehensive set of metadata. So this is the focus of this particular project, Open Embedded project. It provides a comprehensive set of metadata for a wide variety of architectures, features, and applications. And Open Embedded is not designed for it does not have a reference distribution, and it is designed to be the foundation for others. Whereas Yocto project, the focus of Yocto project is to provide a powerful, easy to use, interoperable, well-tested tools. It also provides metadata. It also provides board support packages for a core set of architectures and specific boards. So each of this project has their own particular focus. The main focus of Open Embedded is to be foundation for others. It provides you a set of metadata. The main focus of Yocto is providing you a powerful, easy to use, interoperable, well-tested tools and metadata, as well as board support packages. First, so you can create your own custom distribution. But the important point here is both of them, they share a core collection of metadata, which we call as Open Embedded Core. So we said Pokey is a combination of BitBake, Open Embedded Core, documentation, and Yocto BSP. So this is what Open Embedded Core. Both this project, they share this particular metadata. Metadata, we know it is giving build instructions, which version to use, which patches to apply, and all. We have to fetch the code. So Open Embedded Core, OE Core, the Yocto project and Open Embedded project, they have agreed to work together and share a common set of metadata. You know what is metadata? Recipes, classes, configuration, etc., which is OE core. So if you look into OE, if you look into both the project source code, you will be finding OE core is same in both the projects. The source is same. The metadata is same in both the projects. So this is the important point. The Yocto project and Open Embedded, they share a common core set of metadata, which is called as OE core. Then we have BitBake. So we have learned one of the component of Pokey, which is OE core. Now the next component is BitBake. So BitBake is a core component of Yocto project or Pokey. It basically performs the same functionality of Make. So it is a task scheduler which passes Python and shell script mixed code. So BitBake is a task scheduler which actually parses this particular code, and then once this code is passed, it generates and runs the task, which are basically a set of steps ordered according to the code's dependencies. So the dependencies are, first we need to fetch the source, then we need to extract the source, then we need to configure the source. So it generates a set of steps, ordered steps like fetching, downloading, fetching or downloading, extracting, configuring, applying patches. So it actually generates this such kind of task, and then it runs those tasks. So it is a task scheduler. So how it does, actually reads the Python and shell script mixed code. It keeps track of all the tasks being processed in order to ensure completion. So it makes sure they are completed. So if suppose you have canceled in between, the next time you run the BitBake, it will make sure this is run again. It maximizes the use of processing resources. It uses all of your processor codes to reduce the build time and being predictable. So this is a task scheduler. So like you have make on your Linux, when you use make, right? When you build Linux kernel. For Yocto, we use BitBake. For build root, if you someone is already aware of build root, we use make, but we don't use make here. We use BitBake.